5, Climate and Climate Change. Up to this point, we've talked about energy transfer through the atmosphere. That energy transfer also comes in the form of water and water movement through the atmosphere, which often we associate with weather systems. And we talked about severe weather systems most recently. So with that and understanding how weather is manifest through water or the absence of water or changing volumes and types of water, we can start to appreciate climate and climate change. And if you recall a few lectures ago, we stated that climate is a 30-year running average of weather conditions. So we're looking at the average temperature over 30 years, we're looking at the average precipitation over 30 years, the average type of precipitation, when that precipitation comes, when different temperature regimes over the course of a year manifest, and we can start to recognize some norms. So this time of year, this portion of February, for instance, we have a notion of what type of daily weather we should be getting. We do know that in this part of Ohio, it's not uncommon to get snowfall and really thick, heavy snowfall. It's uncommon to get significant amounts of rain, and it's uncommon to get temperatures of 70 degrees or so. So when you get anomalies, then you have to ask yourself, is this going to be a trend in a long-term condition? Or is this an unusual case? And you can't know until a significant number of years have gone by and that anomaly repeats itself enough times that it's no longer anomalous. And under that condition, then we can say that something is changing, that climate change is occurring. So we ask the question, what is it that scientists really know with climate change? Over time, we've seen predictions made, or at least predictions presented through the media, that haven't panned out. In the 1970s is a really good example. In the 1970s, statements were saying that, oh, it's going to get cold. But that's what was presented to the public. And the public spent some time really thinking about that. And as a child of the 1970s, my mom was preparing for the great ice age that was going to occur. And as an adult, I still had snow boots that she had purchased for me because she was ready for the great snow boot run, where snow boots weren't ever going to be available in the future because the agriculture was going to fail and jobs were going to collapse and we were going to be in some big recession. Not so different than the big toilet paper problem that we had last spring. So my mom behaved similar with incomplete knowledge that many people behaved last spring, with a concern that there would be a lack of toilet paper. So we have a perception that gets built into human behavior with unknown conditions having a little bit of traction out in the public perception. So what we do know is that scientists did understand that we were heading towards an ice age. What wasn't communicated and what wasn't fully understood was scientists didn't really have a solid time frame on when that ice age was going to occur, not like we have now, but they knew that it was going to be significantly long into the future. What wasn't communicated to the public, though, was it was going to be significantly into the future that the temperatures were going to get cold. Now, the 70s were a little colder than the 60s, and so people sort of equated, it's colder now than when I was a kid, so the ice age must be on its way. And it went full tilt, full steam ahead. Public perception with a knowledge base then gets really interesting, because by the late 1970s, computer technology had really advanced. where in the 60s through the early 70s we had computers that would take up entire rooms and you were using punch cards and it would take forever to computate something. By the 70s now, we had desktop computers, which for you and I are archaic, ancient technology. But what that meant were more scientists could work on answering different questions, including climate change. And that meant that they could work more independent from each other and start to really explore different facets of a problem, ask a question differently, and see what the outcomes would be. So more scientists working on understanding natural science, including atmospheric studies and earth studies, could then come to different independent conclusions on what was happening with science. So this allows our science and our earth science understanding to expand and become more robust. We could test more things because we had more people working on testing them with computer technology, and the computers themselves were improving rapidly at the same time. So their computing capacity was also manifesting more greatly. So we had this big push through the 1980s, starting with the late 1970s, to move into better understanding of science overall and natural systems overall, which included climate. So what came out of the late 70s through the 80s was really this understanding that we have already come out of an ice age, which was roughly about 10,000 years ago. And because we were coming out of it, we were still in a warming trend, and we were going to continue on a natural warming trajectory for a period of time into the future. But we were somewhere in the middle of that trend, and then as we reached the apex of the warming, which is still forthcoming, we were then going to move into a cooling phase, which is what was predicted in the 1970s. So the folks in the 70s were correct in saying we were moving towards a cooling trend. What wasn't communicated was that we were still on a warming trend, and the 80s allowed for that natural warming trend to be better understood and better manifest with what were the drivers of climate, such as how does water circulate through the atmosphere, which is what we've discussed. What is albedo? How does albedo drive climate and weather conditions and cloud cover and other earth cycling phenomena? So by the 80s, the scientific community was really well understanding that the Earth is in a warming phase out of a glacial period. And the public was just left confused. And that makes a lot of sense based on what they were given a decade earlier. And when you get that sense of confusion, that builds mistrust with the scientific community.